Hey, I'm Shane Varco, the Executive Director of the Dalgarno Institute. Welcome to our Dalgarno Institute's no-brainer resiliency building sessions. Hey, welcome back. Getting back to safety is an interesting one. Remember we talked about those 4 elements? Well, again, we'll speak about some of those more in depth in another session. But safety is an interesting one. This is a key one. When we feel unsafe, it sets chemical reactions going that mess with your hippocampus and your amygdala, parts of the brain you do with emotional and cognitive memory and storage. So what makes you feel unsafe, afraid, insecure? Now, all of these are types of fear. Unsafe, afraid, and insecure, all types of fear. But all have different sources and have different solutions. Sometimes we have the fight, we have the flight, or we have the freeze response. The ultimate result of the HPA axis activation, which we talked about before, big fancy words, hypothalamic pituitary adrenal axis, big fancy words, but we'll show you what that means in a minute. This is sometimes called the body's stress system. Now you know all about that, so now you know what I'm talking about, is to increase levels of cortisol in the blood during times of stress. So when I'm stressed, when I'm anxious or fearful, cortisol, this chemical response, kicks in. And the cortisol's main role is to release glucose into the bloodstream in order to facilitate the fight or flight or freeze response. In other words, your body goes, oh, you're stressing, you're panicked, you're afraid, and all of a sudden it releases this glucose. So it's like energy, it hits your system and you get jacked. Now, of course, that also releases, and if it's not used properly, that creates other issues in the body. But that's what's happening when you get stressed out. And when you're feeling really unsafe or insecure or fearful, those things can really start to work in. As you can see with this diagram, check this out, spend some time, stop the video and have a look at this and check out how it all works. You'll see the cartoon we've created and how that kind of works through that and what happens to your muscles and your responses during times of fear and anxiety. Now, one particular neurotransmitter is called GABA or GABA, depending on which school you went to. This neurotransmitter acts like an inhibitor in the developing brain. So again, this is another one of those mind and not just brain things. Going back to the recipe model, we see the values, beliefs, and their reinforcers of relationships, behaviors, models, and instruction all add to the development of the pre-puberty brain. So that's to helping develop the way these neurotransmitters work. Now, this helps develop the executive function. Remember that prefrontal cortex where you make your big decisions? You have decision making, planning, all that sort of stuff. And seemingly how we make decisions and how GABA neurotransmitters can help us stop doing dumb, short-sighted things and make better long-term decisions. Now again, all those factors that we just spoke about, your environment, your relationships, your models for living, your values, your rights, your wrongs, all those things are really important in helping you develop the mechanism so your neurotransmitters work in your favour. It's part of your brain break, like it stops you from doing dumb things. The neurotransmitters respond out of those environments and they help become better brain breaks, stopping you make bad, dumb, silly, short-sighted choices, which is really important as your adolescent brain wants to accelerate learning in all its forms. Remember we talked about that whole reward and exploration. It wants to learn, it's hungry for knowledge, or it can jump back into the rebellion and experimentation model. And again, the GABA hormones, along with your behavioural matrices, the things that you've developed, will help you make smart choices. So you move into your acceleration of learning, moves into understanding, exploration, wisdom, and experience, not just experimentation. Of course, if these aren't well developed before you hit puberty and the second stage of your brain development, which is now more learning via action, then your actions, good, bad, or ugly, start shaping your mind. And the decisions, and in turn the decisions, are shaping your mind as well. So you get this loop happening. So again, we want to be as smart as we possibly can, as much wisdom, as much input, as much best practice as we can possibly have in our system as we're going through puberty so we can make the best decisions. Now, the loop, of course, is really important. GABA and that loop. Disinhibitory elements stop the brain brakes from working. A disinhibitor is like something, so when you inhibit something, you stop it. So a disinhibitor says, you know what, I'm going to remove that brake. I'm going to remove that thing that's stopping you from doing that. The disinhibitory elements stop the brain brakes from working well, so you can be more prone to not just dumb acts, but brain damaging ones. Alcohol and other drugs will do just that at this stage of development, faster than anything else. It really messes up the prefrontal cortex motor operations. It messes with your amygdala and your hippocampus and creates an even more dangerous and dysfunctional loop. I think this is a good point to jump into our how not to say yes to GABA messing up alcohol. Now, this is a quick clip put together about how alcohol impacts your judgments of an adult, let alone a teenager. Check this out.
The effects of alcohol obviously increase the more we drink. And while it's difficult to say how many drinks equate to specific effects, there are so many factors involved, such as food intake, gender, weight, and other things. We can approximate effects based on blood alcohol concentration, or BAC. At a BAC between 0.02 to 0.03, perhaps one standard drink, there are very few obvious effects, with only a slight intensification of mood. After 2 to 2.5 drinks, in the first hour, your BAC climbs to about 0.05 to 0.06, and you might experience a feeling of warmth, relaxation, mild sedation, and you're likely to start talking more and feel less inhibited. These effects all happen in the brain's frontal lobe, which is responsible for stopping us from doing and saying socially inappropriate things. When alcohol enters the frontal lobe, it impairs our ability to control our behaviour. At a BAC of 0.07 to 0.09, your speech will start to slur and you'll not be as balanced when you move. There'll also be a decrease in reaction time and coordination, hence the legal driving limit of 0.05 in Australia. Your hearing and vision will also be impaired. And it's pretty much just downhill from here. At a BAC of 0.13 to 0.15, you'll have significant loss of coordination and balance, blurred vision, and your judgment will be severely impaired. Most people will start to feel nauseous and may start vomiting if their BAC gets to close to 0.2. At a BAC of around 0.3, you'll be in a state of near unconsciousness, if not unconscious already. Coma is possible at 0.35 and up, and death is just around the corner.
It is important to note that the statement positive emotions is not the same as the idea of sensation or even feelings. Emotions are the result of more complex interactions that release a biochemical response. There's other stuff going on than just chemical interaction. This is really important, guys. We think that we can just play with a bag of chemicals. If we manipulate a chemical, we get a response. Now again, positive emotions, I'm going to reiterate this as much as I can. Positive emotions are part of the mind development. It's not just a brain response to a chemical transmitter. Positive emotions are to do with all of, not just your brain, but the way you are. So emotional, relational, environmental, all those factors develop those emotions. It's not just a sensation or a feeling. A drug or a chemical can give you a sensation and even a feeling, but it will not create an emotion because there's a lot more involved in that. That's a really important distinction, and that's going to mean more as we move forward. GABA and tricky copies that don't last. Now, this is where it gets interesting. The chemical release of neurotransmitters created by the brain around all the environmentally induced hope factors that contribute cannot be replicated by overlaying the same brain with artificially created and introduced neurotransmitter copies. Now, this is really key. As I said before, I'm going to reiterate this. Your brain and your mind and your emotions and your will all come together, and the brain and the mind creates this sense of euphoria that's more than just a feeling. It's got meaning attached to it, and it's really important. And that's what your mind and your brain and your being creates with the will, your agency and your capacity comes together to do that. Now, your mind is creating that healthy way forward. Now, some people think, okay, we can just copy a neurotransmitter and overlay that on the brain. That'll give you the same outcome. It doesn't quite work that way. And it's often just short-lived. It can work, give you a similar sensation, but it doesn't create the same response. And it's interesting, hope factors have far more tenure, strength and longevity than a chemical overlay. Because what it does is it's recalibrating your mind and recalibrating your will, recalibrating your emotions. And all those things start to work together to help your brain become more resilient. But overlaying it with a chemical doesn't do the same thing. It gives you a short-term similar response, but it doesn't last. And simultaneously, it only deactivates the brain's ability to do it properly. So what it does is the overlay of the mimic, the copy, if you like, the counterfeit, gives you a short-term response, but it actually deactivates the brain. So the brain goes, oh, okay, something else is creating this GABA, this hormone, or this neurotransmitter, whatever it may be. It may be dopamine, it may be serotonin. The brain goes, oh, something else is doing it for me. So it just slows down its production and obviously undermines the capacity part of what you're doing, you're developing as a human being. So you see what happens, guys? It just actually stops your mind from developing and you from maturing. Rewiring cannot successfully be done chemically. Well, not at this point in our scientific history. They've still been trying that. They've been trying it since the 60s. It needs more than that. It's not just a chemical overlay. We just can't go, place that there, you're fixed. Because it's a whole of person, a whole of brain, a whole of mind response. That's where the science is struggling to get forward, because we need more than that. It's in our resiliency rope, problem-solving skills, persistence of will, all those kind of things are really important, and chemicals cannot generate that. Today's conversation starter. So I want you to discuss with your group, your team, your class, what are some of the things in your broader social environment, your peer settings, your friends, your social media, that make you feel A, secure, and or insecure, and why? B, share with the group, if you feel safe and you have a confidential space, share as a team the things that make you want to fight or flee, run, and the things that make you freeze up. You know, what are the things that make you freeze up, whether it be family, socially, class, sport, work, whatever it may be. And finally, what tactics have you found helpful in dealing with those situations, and what have not been helpful? And share as a group and give each other some encouragement. Okay, our script builder takeaways for this session. I want you to write these down in your journals, and you can add to this later, and you can, make some notes around this as you want. As a group, list the things that have a negative impact on you and put next to them one thing you can do to change that. Also share with the group and add to your resiliency script journal the things that help you not react fearfully. Number 2, a chemically prescribed chemical intervention in a crisis can act as a circuit breaker in a sense of overwhelming emotions and feelings and sensations. But the doctor will tell you that they are not a long-term solution, and you need to develop the other areas. And finally, most definitely, self-medication with illicit substances and alcohol will only sabotage your capacity to get better, and in fact will continue to diminish both your health and your well-being, and ultimately your resiliency capacity. This particular session, we're going to end with a video clip. Twice in this session, we're going to look at how not to say yes to a drug. And this particular session is how not to say yes to psychosis-inducing weed. This was an excerpt from a lecture given by Professor Murat Yassel, and it's a brilliant insight and good for a takeaway to understand how self-medicating with weed is absolutely an undermining element in your well-being, not a helpful one. Until next time, be well.
The first conclusion is that heavy cannabis use is associated with brain volume, in some regions by up to 24%, and memory impairment, as well as psychotic symptoms, subthreshold psychotic symptoms. The second conclusion is that we think, and we have evidence, that actually with respect to the hippocampus, which is one of the main neurobiological correlates that we find of heavy cannabis use, that it's actually a consequence of cannabis use. It wasn't there beforehand. And I'll show you some studies that support that idea, but there are other regions of the brain which are different in cannabis users before they start using, which mean that maybe it's a risk marker. So the hippocampus seems to be a consequence. There are other bits of the brain which seem to be different pre-existing. Then, if we drill down a bit more on the neuroanatomy, we do see that in certain parts which are most heavily affected in cannabis use, that you can have up to 80% reduction in some of the fibres, the white matter fibres going through parts of your medial temporal lobe. And there are also neurochemical changes which, based on what we know about the chemicals that are different, indicate that that's not a good thing. I'll show you that exposure during early adolescence leads to more harm. And I'll show you some data that also suggests that if you already have a vulnerability like a mental illness, and then you bring in cannabis on top, that the effects are additive. That you're doubling the kind of harmful effects. And then finally, and a bit more speculatively, that regular use and early use actually significantly amplifies your risk of a psychotic outcome in the absence of other risk factors maybe.